the greatest honor in the robotics industry of the Association of America is to be named the winner of the Joe Engelberger Award. And Red Whitaker has been given that name, as has Pio Carnegie. The only honor greater than having RIA name you Joe Engelberger is to have your mother name you Joe Engelberger. We are very pleased to have with us Joe Engelberger, who is the father of robotics. Now, I could read about his Progress Award and his Leonardo da Vinci Award and his American Machinist Award and his McKechnie Award and his NAE membership and his Eggleston Medal and his Beckman Award and his Japan Prize and so forth and so on. But far better than listening to me talk about Joe Engelberger is having us listen to Joe Engelberger himself. So please welcome Joe Engelberger.
Well, thank you, Chuck, and thank all of you for coming out to hear what I have to say. I'm going to talk about robotics, obviously. I'm going to talk about the fact that I have a personal diatribe, and I'm going to emphasize that diatribe because I haven't got that much more time in this industry, and I'm a little bit concerned about where the industry is going, and I'm hoping I see a room full of either roboticists or would-be roboticists who are going to make the difference in the future. So I'll start out with slides. I have some videos as well, and I'll get myself out of the way of the slide projector. Obviously, they've made their mark. And if you are in industry, and if you're doing any of these things, if you're not using robots, you're losing money. All of those jobs, and maybe just a very few more, would fill the list. Now, that's the one that is being honored out here today. This afternoon, it's the Unimate. It's the very first robot. It was hydraulically powered. It went to work in a General Motors plant in 1961. It ran for something like 50 man years. That's 100,000 hours of actual time on the job. And it had many brethren after that. And then subsequently, General Motors again joined with us to build the first commercial electrically powered robot. And they came in 3 sizes, although the first size was the middle size. It's called Puma. An interesting story why it was called Puma. General Motors decided that everything that goes in an automobile weighs less than 5 pounds. That may be surprising when you think of the big sheet metal, but they said, we got to assemble it with robots. So we'll make a machine for assembly. It was a conveyor belt, it had loading stations, and it had a robot on it, one of these robots. They call it Programmable Universal Machine for Assembly, the whole thing. The press came in, they didn't pay any attention to anything. This is, that's the Puma. Well, it took me 3 years to get General Motors to abandon the right to that name, because I said, you're never going to be selling Pumas to anybody, but I'm selling things the press call a Puma. And so that product came into being. Now, the axe that I want to grind, and have been grinding for a while, is how about putting the robots to work in service applications, not just in factories. We have a lot of things going on in factories and automation already that's reducing the opportunities. You may know that industrial robot business is depressed along with much capital goods. There are plenty of places where robots should be used in the service arena. These are some of them. I happen to have been involved in the first one, the hospital porter. There's a product called the Helpmate, which is in a hospitals. It travels up and down 10 more stories of hospital. It goes up and down elevators by itself. It knows where every department in a hospital is, and it works at a low hourly rate. There's some 150 hospitals in the United States are now using the hospital porter. Each one of these things, while they may not be big yet, and they may not be commercial, my own feeling has always been that the robot's a great product when it makes somebody a profit. Up to that time, it's fun and games, but and so far, there's a few things. A parasurgeon right now is probably not a robot. That's the other thing to remember, that we've lumped everything together. That's a telerobot, or telecheric, some people call it. Basically, there's a man or a woman in the loop, so the robot runs. Now, isn't it wonderful that you have say a surgeon, a brain surgeon. He's now 65 years old, his hands are shaking. He can't do brain surgery anymore with shaking hands. But if we put a robot in between, we will take the shake out of his hands and we'll expand the motion of his hands go through in comparison with the very small motions that the arm goes through in surgery, brain surgery, eye surgery, and so forth. It becomes a very important part of surgical operations like hip replacement, laparoscopy, where there used to be an intern standing there running the camera in your belly, and then the doctor would go through 2 other holes and he'd do his procedure. But if the intern ever touched something fluid, the camera would get clouded. He'd pull it out, clean it off. Also, when the doctor is working and he can voice control that camera, he can say, go back 4 steps, and he'll go right back to look at something he looked at before. So it's a great field. It's just not a standalone robot. Now, I'm talking to a lot of people today about the opportunities in farming, whether it's harvest or planting or weeding, they're there. The hotel bellboy is just an extrapolation of the hospital robot. And my cause célèbre, well, I can't skip military combat because I don't like it. Isaac Asimov didn't like it. You may remember that he said, a robot must never harm a human being, and a robot must always obey a human being. And a robot may then take care of itself after the first 2 rules. And our military and other militaries are not paying much attention to that rule in trying to develop combat soldiers. My cause célèbre is the companion for infirm or handicapped. I've looked again at the themes of science fiction, and you go back to how people looked at this robot game way back. And there's 2 people that come to mind. One is Isaac Asimov, and the other is Ray Bradbury. Now, Asimov made his robots like one of these. Gets around on its own, works on its own. It may be smarter in some ways, maybe stronger in other ways. But his robot was a humanoid. Ray Bradbury had a different approach. He said, let's make the whole house a robot. So one of his famous stories, the house is completely a robot. But there's a nuclear war and all the people die. The only thing still alive is the house. So the house delivers meals to a table, waits for a while and sweeps the table away, smashes up the dishes and makes new dishes. Little mice come out of the wall and they clean up after it, and this house just keeps living on even though there are no people. Anyway, obviously I'm favoring the standalone robot. It's not like an industrial robot locked to the floor in one place, but it allows to work with you in your environment and hopefully in elderly people's environment. Now, another thing that's important that they may not have let on Carnegie Mellon, there is a tremendous amount of technology already available. We have a lot of technology. Time and again, I read papers that come out of conferences, and I wonder, what on earth are these people doing? These papers are no good for anything but the bibliography of the next guy. It's been done before. We need more work that's at leading edge. So here it is. You've got, you know, in the industrial robot business, I used to joke with customers and say, look, I'm going to sell you the mechanical robot. I'm going to give you the electronics. And I'm going to rent you the software. It's that combination. Electronics is so cheap. Memory is so cheap. Servos, we have a variety of them. A lot of controllers. Software, I had listed up there 3 of the proprietary softwares, but today there's a lot of open architecture software that you can just rent. We have position sensors of great varieties. We have range sensing, whether it's ultrasound, light triangulation, LiDAR, optical flow. Every one of those different techniques are available. And it's important that they're available because just like we are multi-sensate. We can depend upon different senses at different times or even at the same time. So for our robot in the hospital, it has both ultrasound and optical vision. Well, now if the robot were looking at that window there, standing here, and there weren't those shades in the way, the light that the robot sends out, see, we don't send light out, we only receive light. The robot sends out would go off at an angle. It would bounce. Effectively, the window's a stealth object. So we want multiple sensors to be able to use. Now, ultrasound would get the signal back under those circumstances. Okay, the tool chest continues. In vision, we have a number of different things we now do. Very important today is scene analysis. So that if you look, you just don't find something there, which we do for navigation. Find something there and don't bump into it, but find out what it is. And you'll see that in a household robot or a caregiving robot, you need that. Tactility. If you're doing something with vision, you might even have the gripper, your hand, and you probably notice it. When you go into the refrigerator, your hand obscures some of the things the vision is seeing. But right then and there, you're quickly able to transfer to tactility. And you sense it either at your fingertips, which identifies it, or in your wrist, which says how much force I have to apply to lift this thing that was in the refrigerator. Artificial intelligence, the helpmate robot in the hospital has 1,400 rules in an expert system. A lot of what, if this, then that, if this, then that. So you get all that experience so that you know what happens if someone's in the way in a building. You know what it means if you come to the elevator and it's crowded people in front of it. Each one of the instances are built into it from experience. Very few people seem to understand that voice communication is an absolute given, solid. Now, it's not a given for any speaker, but for speaker specific. If I have a patient or anybody and I let them talk to the robot for maybe a half hour, at the end of that time, that voice recognition system is going to be able to communicate just like another human being, if it's speaker specific, so far. Now, the humanoid robot is what I want to talk about next, but what I'd like to do first, if it's possible yet, is it possible to do the video or not?
We mean applications of machine learning. I assume that you're talking about, in contrast to hand-encoded rules in the expert system.
No, some of the rules you know without even doing the experience. You just know it from watching what's going on. So you have a rule, for example, when you get to the elevator, don't stand back and be polite. Because if you do, people will run in front of you and take the elevator away. So when our robot gets to the elevator, it knows it comes right up there and bellies up. No one can get by it. We don't care if they come with us, but they can't stop us from getting in. So we get on the elevator, turn around, and we're ready. we've already called the elevator for what floor we want, and we've done all of that. And now we know that that rule is, and we learned that, actually. We learned that we would lose the elevator time and again because people would take it away from us.
But when you talk about learning, you mean you as the designers learned that rule?
Yes, right.
As opposed to machine learning was used to learn that rule automatically?
Yeah, yeah, right. I know. You know, one of the things that bothers me about some university research is they want the robot to learn by itself. I mean, it's sort of a golden rule. Please, I want to take this blob that doesn't know anything, and I want to let it roam around and slowly get smarter and smarter as it looks at the environment and sees things, and that it'll be an intelligent being just by itself. That's an exciting prospect. But you know, if I were to hire you and you came into my factory, and the first thing I'm not going to say to you is, all right, your first job is see if you can find the bathroom. I'm going to tell you where the bathroom is. You know, and why not? We tell little kids where the bathroom is. Why do they have to find it on their own? But an awful lot of learning comes in the state of by experience. Let the robot sense something and then find out what it should do next time. So what I'm aspiring to and saying it's very logical to do it is to build a humanoid robot. That doesn't mean it's got to look like a Stepford wife. It's got to be feasible in size, muscular speed, intelligence. It's got to use our machines. It's got to use our database. And it's got to function in our environment. Now, some of you have probably seen ads of the Roomba vac. It's a little vacuum cleaner that runs around the floor, sells for about $150. Electrolux made a vacuum that went around the floor for $1,500. Now, it turns out that there's 4 or 5 of those been developed in the United States. None of them really work. Now, the beauty of Roomba vac, and I told this to Rodney Brooks, I said, the ingenious thing you've done, as long as you can't do it, make it cheap. That's it, you know, here you are, I got to buy a present for a mother-in-law for Christmas. You can spring for $150. Put the thing on the floor, turn it on, have a drink, and everyone watches it go around for a little while, then you leave. You know, vacuum cleaners, people use a vacuum cleaner in the United States about 100 hours a year. So now you got some economic problems here. 100 hours a year is all we use it on average. Another thing is that you can't really clean a rug unless you've got 3/4 horsepower. You've got to really drive to get the dirt out of the rug. Can't do it with a battery-powered machine at all. So you got a toy. If it's a toy, price it like a toy. So if you look at when I say use our machines, I want a robot that's going to take our vacuum cleaner and vacuum. It's going to take our things and clean the windows. It's going to use our dishwasher. It's going to use all the same things that we use. Then you get a return on the robot. It's got to go through our doorways, right? There's the first. That's Electro and his dog Sparky. Let me get out of your way here. That's the 1939 World's Fair. Now, the technology that ran Electro and Sparky is the same technology we had in the 1400s to make little automatons that played the piano and danced a little bit and so forth. Gears, cams, wheels, springs. They had one other thing. They had a tape recorder for voice, so it could speak. It did not understand anything. It could speak, though. Very popular. It happened to be a Westinghouse, in a Westinghouse booth at the New York World's Fair in 1939. And here's what everyone expects. Now, I know that this afternoon or this evening, we're going to be honoring R2-D2 because the idea of this museum is going to be pick something from the science frontier, something from entertainment, and something from the industrial world, which is the Unimate. The gentleman who was inside that is here today and will be here. He's being honored. He's a small gentleman who fit inside of R2-D2. And he's still with us. He made it a pretty smart gadget. This I call my rogues gallery. Every one of those robots is supposed to be a service robot. Every one of them failed. None of them amounted to anything. And why is that? Because people thought that the first thing you do is think about the price. I don't know, I think a home robot in the home ought to sell for maybe $1,500. For $1,500, you can't do anything. It's not possible. So everyone in the robot business who wants to be commercial, not just doing a research paper, has got to look at cost benefit, or to broaden it, cost perceived benefit. So if you're going to pay so much for something, you got to think you're getting value. Now you can get that from maybe Ibo, the little dog, because it makes you happy, but you can also get it from something that functions. This little one over here, the black eye there, that's Nolan Bushnell's. That's called Bob, brains on board. He spent $10 million on promotion, and he never got anything more than pretty literature. He thought he could make a robot, but it didn't do anything. You got to do something if you want to get a real return. All right, here's a larger version of a CMO. This is the Honda walking robot. Another thing that I find very discouraging. First of all, it's an engineering accomplishment, no doubt about it. That machine can walk, and it walks, it turns around in place, it goes up and down stairs, but it doesn't do anything but walk. And it has 9 articulations in each leg that have to be controlled so it can walk. Now, if you have some older person living in assisted living, they don't put him in a multi-story building. The robot doesn't have to go up and down stairs. Put it another way, if you had a robot, then you wanted it to go up and down stairs, you can buy for $1,800 a thing that goes on the side of your stairs, you push your wheelchair on it, and it takes you upstairs or downstairs. Don't give the robot legs. As I like to say, if the wheel hadn't been invented, I would invent it. The wheel is the way to get the creature around. Now, that robot has all its power from batteries. They're up here on its shoulders, a very unstable place to have the battery. So Professor Inoue of Japan University is saying he's worked on this. He'll go up to the robot, and the robot will be heading someplace, and he'll put his hand on his chest and try to stop it, and the robot will start pushing harder and harder because it wants to go where it's going. He pulls his hand away fast, it falls on its face. Now, if you want this robot to help somebody get out of bed, it can't fall on its face. It should be on wheels. Now here's something from MIT, another great accomplishment. So, a giant step closer to robots that walk, talk, and think, but nothing about do they do anything and have feelings. That thing has facial expression, theoretically. Sometimes it smiles at you, sometimes it's mad. So what? I don't want a robot to talk to me. We can
for carrying out a broad range of household chores. We can get a partial answer by observing what industrial robots are already doing in factories. Here, robots are using vision to find randomly located parts on pallets and on moving conveyors. And of course, the toilet.
Is it going to leave a seat up is the question.
The toilet is probably the most demanding cleaning chore. cleaning actions have been pre-programmed, but absolute locations are not necessary for the robot or for its arm motions. Machine vision and tactile feedback let the program adapt to the tasks at hand. For example, wrist force sensing allows the robot to apply the right amount of scrubbing force to the toilet bowl surfaces at all times. In their industrial tasks, robots often control peripheral equipment, commanding doors to open, dies to close, processes to start and stop. Often manipulation must be very precise, as in hot glass ladling, or when building up ceramic shells for investment casting. This is a short scene of beta testing of our Helpmate, a robotic nurse's aide at Danbury Hospital. The Helpmate has in its memory a map of all hospital corridors and departments. It uses sensory perception to compare its travels with the map data. Wheel encoders measure distance traveled and turns made. Ultrasound and infrared allow the robot to follow walls and detect corners and doorways. Optical vision, using structured light, tells the robot where unexpected obstacles may be and if they are moving. With so much traffic in hospital halls, safety is a controlling factor, and if all else fails, bumpers stop the robot in its tracks. The software deserves special mention. It must digest all of the sensory signals to evaluate relative quality and importance, and continually compare data with map-driven expectations. The Helpmate structured light system enables it to identify objects that stand out on the floor scene ahead. It sees the distortion in the light pattern, which is sufficient for obstacle avoidance. We see more detail, but that's not important to robot navigation. In the house, there are so many diverse tasks that a robot must have great manipulative power. Sometimes one arm will suffice, but two arms make other tasks much easier. This scene shows a single robot arm carrying out a complex series of movements at a single workstation. The scene was created for the Merv Griffin show using a commercial 6-articulation robot arm. To manipulate tools through such intricate maneuvers requires a 6-articulation arm. 3 articulations deliver the tool to the work zone, and 3 wrist articulations establish orientations. This window washing and plant watering job, desirable though it may be, is certainly not justification for building a special robot that could roam around the house and wash the windows. It would not be cost effective if that were all the robot could do. The TRC household robot was designed with a broad range of tasks in mind, and the articulations, their reach, and their weight-carrying capability were specified on the basis of detailed task analysis. As an aside, one can observe that some institutional roles that are more repetitive than housekeeping would probably need less manipulative sophistication, say hotel bathroom cleaning or French fries production. Robotic researchers today are making great strides in what roboticists call end effectors. Of course, an ideal end effector would be a human hand. This 3-fingered version by Professor Salisbury at MIT comes fairly close. It provides a great deal of finger manipulative power, which one day could be quite useful to a household robot. Other researchers are developing artificial skin to coat fingertips for sense of feel. Actually, the TRC household robot beauties won't depend upon these developments. Our robot will use interchangeable grippers and quick disconnect wrists to match end effectors to the tools and jobs. Even with high-resolution manipulation, positional accuracy is not enough. Interaction forces must be sensed. Deburring is a case in point from industry applications. Risk force sensing is also important for sensing that something is wrong in a program, that an insertion won't work for some unexpected reason. When force limits are reached, program actions can be aborted.
Clean the bathroom.
Yes, sir. Clean the bathroom.
Isaac, please. Fetch soda.
Yes, ma'am. Fetch soda.
Isaac, please. Wash the car.
Yes, ma'am. Wash the car.
Well, I just got through saying this business of making the robots try to look at something all the Japanese seem to be working on, make it look friendly. And I think that's all based upon the fact they had this boy robot in their movies for the last 40 years. And that's what everyone thinks a robot should be like. But that's a waste of technology. And it says closer to robots that walk, talk, and think. But it doesn't say it's doing anything and have feelings. Who cares about the robot's feelings? You probably recognize Ivo. That's a silly business. That little robot can't walk over a 2x4. It can see a red ball and a green ball and nose them along a little bit. It has only one thing going for it. It really doesn't crap. Now, in Eldercare, there's tremendous saving potential just in the United States. And the quality of life is improved. The nursing home is the kiss of death for an older person. The last thing they want is a nursing home. That runs $60,000 to $70,000 a year in the United States today. And that's cheap compared to having household help, which is considerably more expensive if you have live-in help. My daughter went around with the Visiting Nurses Association to talk to people, see what they would like, didn't like. And they told her that, you know, sometimes the most important thing we do when we go into a home is let the caregiver go outside and scream. It's such a strain to take care of an old person hour after hour, all the time, and put up with their idiosyncrasies. Another reason why it's become so important. Here, you know, Germany, France, England, all over. In the 1900s, we tended to die before we became disabled. Today in the United States, the fastest growing age is 85. Almost everyone at 85 in that range is disabled in some way. So that's a market condition. And what's it going to do? Well, it's going to fetch and carry. You're going to ask it for something, it'll know where to go, whether it's the refrigerator or the cupboard or wherever. It's going to prepare meals. Now, it's not going to go out to the charcuterie and pick out the cut of beef that's perfect for the next dish. But you know, 95% of everything in a supermarket is now barcoded. So all you have to do, the barcode now tells the clerk what to charge you for it. Very easy to add to that the recipe. And the recipe then is enough for the robot to work with. It should clean house. And as I said before, it should use our tools to do it. Should monitor vital signs, which is straightforward. You should be able to always determine blood pressure and pulse and the things like glucose levels. There's a number of things that the robot could check and report on to a remote human doctor. Assisted ambulation. In the United States, according to that geriatrician that you saw in a previous film, said 200,000 older people fall and break a hip every year in the United States. Now, if they're 65 years old, we'll patch them up, but if they're 85 years old, they'll never walk again. Now, what happens in the house where there is a caregiver? Someone sitting there watching television has to go to the bathroom more often than a younger person does. They don't want to ask a caregiver, please take me to the bathroom. So they struggle to get up, they fall and break a hip. Now, if they'd had a robot instead, who cares how often you ask a robot to take you to the bathroom? Fine. It's the kind of relationship that would help. Manage the environment, of course, is already a given that you can do it pretty well. Communicate by voice, we've talked about. Take emergency action. A lot of older people have a hearing problem. They may have an alarm in their house. The alarm goes off, they don't hear it. If there were a robot in the house, robot would wake them up, shake them, get them out. Meanwhile, it would have called already, the system would have called the fire department, and then the robot goes back and fights the fire. That's not so funny. It's been experimentally proven in a number of places that it's one of the easier things to do to sense heat and flame. And picking up a fire extinguisher and going to heat and flame is something that the Japanese did 20 years ago to show the potential. I tell you what, we worried about intrusion. So we went to the FBI and we said, what can we do about intrusion? He said, well, the robot would say to whoever came in the house, what's the password? It doesn't make any difference because the robot only cares about voice print. Doesn't care what that person says. But if it's the wrong person, you can say, look, you don't belong here. I suggest you leave right now. I've already informed the police of your presence. And if you don't leave, I'm going to take aggressive action. So we said, well, what kind of aggressive action? Well, you know the law, until a person hits you, you're not allowed to take aggressive action. You can't, theoretically, use a gun on an invader. So well, you could use mace, you could use any kind of a spray. But then they showed us something that they had developed. It was a handgun. And you know, when you have a New Year's party, you have these noisemakers, you blow, and it comes out in a big curl like this. And they had a gun that had about 7 strips of sticky tape, sticky on both sides. They went out about 20 feet. And they aim it at somebody and just wrap him up. And that's something a robot could do. Well, these are just some pictures of the kinds of things that the robot of the design we have would be able to do. You've already seen that before. And helping someone out of bed. And bringing food. And just helping them get around without falling down. That's the picture you saw earlier, but basically this artist's conception. It has 7-axis arms. The trunk moves up and down. I was talking earlier to Takeo, and he talked about a Sony robot that was so high, and I said, well, how can it reach anything? How can it do anything if it's just a little rascal? It's got to be able to reach up to the ceiling, reach to the floor. And this is a picture of something we did for NASA. Very definitely highly experimental, but it was 2-armed, had stereo vision. Ultrasound had the navigation ability of Helpmate. Now, from a person in a house, Helpmate goes around 8-foot wide hallways. This is too big for a home robot. It would have to have a smaller footprint. It's essential, I think, in the house that it be holonomic. I assume you know non-holonomic, things that the wheels turn, you park by jiggling around. A holonomic car would be able to go sideways into its parking lot. And that's easy to do with a drive on a robot. This other picture just shows how far it can reach. So now I think I've just about run out. I have about a 6-minute video of how this thing worked a little bit, which maybe we can still put on, but I'll show you again. Remember, this was it. Use our machines. What do you need to be successful? These are the things you need. It's got to be a magnificent physical execution. Can't be junk. A hero robot can never be saved by software. It's not good enough physically. So it's got to be physically right. It's got to have a spectrum of sensory perception so it can cope with the world we live in. Now it needs a quasi-structured living environment. It's not going to go into an old English castle, but it should be something where you know that this is a living room, and that's a kitchen, and that's a bedroom, and this is the bathrooms, and here's how they work. We want to give the knowledge to the robot as much as we can. So I don't want to put it in the room, as I said before, and have it try to find out about the house. I'm going to tell it about the house. And the cost-benefit standard for the development team. I was saying earlier that when we built the Unimate robot, we sold them for $25,000 a piece. The first one went in 1961. They cost us $60,000 a piece to make them. Well, the people who put the money in our company didn't think that was a good idea. So they hired McKinsey and Company to come in and look at manufacturing of this. And they said, you build it up to 200 a month, value engineer it, tool it, you can make that same robot for $8,000 a month. Now the $25,000 price made sense. But we had to start out, and you always have to. You got to price it so the market will appreciate it. Then you better know that you can get the cost down so you can make money with it. Those two things have to match. Yeah, a few things. Kinds of things Red's doing where you're solving a health problem, or you're solving a problem for the government that, like let's say in space or in nuclear power, where the cost can't be evaluated strictly on the basis of separating a human being. It's got to be evaluated on the danger, the hazard, and so forth. But I've seen so many places where people forget cost-benefit. And that's one of the things. Now, I have another little video there, but I don't know if we have time, but I'll just finish with my... I happen also to be very much an amateur painter. And because of my frustration with not being able to get the support I wanted for this whole program of an Eldercare robot, which I'm so confident is such a market which by and of itself is larger than the entire industrial robot market today. That many people are going to want this. And not even talking about people who just want it because they want it. They want it to serve drinks at the cocktail party, but the people who need it. So I call this on the shoulders of giants. The Unimate and the Puma. And the things they know and the technology they have, but on their backs, we can have an Eldercare robot. Thank you. I don't know if we have time. If you have time, we'll run the other.
Of course we have time.
Okay.
The question is, do we have technology?
How old was the first video?
Pardon?
When was the first video that you showed us made?
It's about 8 years ago. Yeah. You know, the terrible thing, it was that long ago, because you could make it today and you wouldn't have a lot different to say. That's why I'm upset that we had this stuff and we should have been doing this. We called that version you saw at the end Isaac, only because in honor of Isaac Asimov. And you'll see that I get to be the guinea pig in here because I was the oldest one in the company.
And this video is from when?
Oh, that's a couple of years now.
Isaac, could you please help me up? Coming, sir. A little closer to me, please. That's better. Thank you. What's up? Thank you. Isaac, I'm thirsty. Suppose you could bring me a glass of orange juice? That's fine, thank you. Cheers. You're a good help, sir. Isaac, how about your stretching exercise? Let's see how far you can reach. Happy to do so. Come on. Okay, to the floor. Can you move apart? That's good. I'd like to see if you can reach the ceiling. Whoa! Well, that shows the whole thing. Bring your arms back to this position. Thank you very much. What do you think, everybody? Isaac, what day is today? Thursday. Oh, you're not going to forget the garbage, are you? Great mind, sir. That's what I'm doing now. Isaac, what's for dinner? Healthy choice, chicken stir fry. And for dessert? Neapolitan ice cream. Jolly good, thank you. Sir, Dr. Hennessy asked that I take and report on your blood pressure and pulse before you take your beta blocker.
Okay. Well, as you can see, that was built up with a lot of hardware that was available, a very limited budget, and we just pushed that out before we shipped the whole thing to NASA just to get a little view of ourselves. But if you look beyond what that was into what we had in the video, I'm prepared to argue with anybody that we can do it. Now, I had set a standard for some people. I said, we'll build that, prove it completely, design it for tooling. I want $3 million, $5 million in 3 years. And, you know, this was all, we started this in the time of .com. And the minute you said 3 years to those people, their eyes would glaze over. You know, 3 months is more like it with software. And that was before they all went down the tubes. But in any event, I tried to say that, you know what, we can build one the right size, a holonomic base, prove functionality to satisfy anybody. We can do it in 14 months for $700,000. That will not be ready for production. It won't be value engineered. It won't be tooled, but it'll have had alpha site use at least. And I said, as a demonstration of my conviction, I will put up 300,000 of the 700,000 myself. Now, I don't want just another 400,000. I want someone who's in a position to manufacture and market. Those are not easy things to do. You can't get it out of nowheres. So if the partner I find, and I've been looking at Europe, I just got back from South Korea talking to Samsung and others. Somewheres I'll find someone who will see the potential for an Eldercare robot. And if you make robotics your career, there's a hell of a lot more to be done. So plenty of room for more accomplishment. And for all of you who become roboticists, I wish you the best. Thank you.
you just showed us, was any of the speech recognition, speech understanding or natural language generation real, or was it all sort of artist conception?
No, what we did, we taught the robot the things that it could say under the different circumstances. Not many, we didn't many phrases in, and it understood what we said. That we did. That's so easy that it was just easy to do. Just teach it, and it knows. And it's not you can do anything. The problem is, it's always speaker specific. Today, I mean, you know, on the telephone, you're going to get the numbers 1 to 10 and yes and no for anybody, no matter what country they came from. But for speaker specific, you can have a whole. So you had 100 commands, that'd be nothing to a robot. Also, conversation is even possible. You know, it was many years ago, there was a program at MIT called ELIZA, and it was a computer program that was purported to tell your fortune. And they told it just like a cold reader did at the Copacabana. Basically, it would analyze you and keep leading you on with conversation until such time as it got a pretty good picture of what you wanted to hear. And they would feed it back. And people thought they were being psychoanalyzed by the robot. Now that didn't have voice communication. It was all done with keyboard. You know that helpmate in the robot? Everyone anthropomorphizes it. Even though it doesn't have arms and it's just like a box. We put candy stripes on it so it looked like nursing belts that went around. People love it. They love to talk to it. One of our customers who has 6 of them said, we may save a lot of money, but the nice thing we got out of it is we got public relations that said we are a very advanced hospital. Because that robot struck that way. We had a funny story that we had, one of our engineers was just going through some of the program and see how the thing is programmed. Ordinarily, you get all the drawings for the hospital and use them to generate the first programs. You do it all offline. A lot of hospitals have their whole thing on computer anyway. But it's never exactly the way the architect designed it. The hospital is always a little different. So you have to go around and teach a couple things because this hallway is shorter than we thought it was or longer than we thought it was, so forth. So anyway, he was on the pediatrics floor and he had the robot there and he was going to send it to the 6th floor from the pediatrics floor. And a couple kids came out, wow, what's that? You know, it's a robot. What's it going to do? He said, well, I just told it to go to the 6th floor. Elevator doors opened up. Robot got in, turned around. One of the kids looked up at our engineer. He sticks his head in the door and he says, hey! He didn't know. We told him this way. So that's, right away, anthropomorphization is there. You don't need to look like a person to be taken for a robot very fast. Yeah.
Grant, we had ceded the huge market to the Japanese, and by 2000, it would be gone. That is, the Japanese market would already, the Japanese manufacturers would have dominated the U.S. Eldercare marketplace, which obviously hasn't come to pass.
Hasn't come to pass, no.
So the question is this: when you go to speak to rational people,
Yeah.
and they choose not to fund your generous offer of $300,000 from your own money,
Right.
on what basis do they reject it? I mean, your proposal is passionate and well intentioned, but I want to know why hasn't it come to fruition?
Well, first of all, there's a lot of people say it can't possibly be done, particularly non-technical people. And non-technical people are at a high enough level to say it can't be done. And then, you know, I had an expression. You get to the Vice President of Corporate Development, and he says he'll back anything that's a proven product. That's the trouble. If I've already proven it, you're willing to go. The Japanese are a shining example. I was a guest of the Japanese government in 1964 when we had one machine out in 61, as I told you. First time in my life I ever flew first class. Got over there and they took me around to all the shrines and it was just a wonderful time. And at the end of that week, we went to a conference. It was 500 executives in that conference. There was a time in the United States when I couldn't get 10 people to listen to me. So 500 people asking questions. But what happened? The Japanese people, I've been there 38 times. I have a lot of friends and I like them. They're usually very polite. They said, suppose nobody asks a question. we better write some out for you. So we sat there and we wrote on little pieces of paper some questions, which I'd have ready so I wouldn't be embarrassed. I got on the dais at 1:30, and they dragged me off at 5:30. And the questions came, and the Japanese had a Japanese Industrial Robotics Association 3 years before we had it. And they went into industrial robots, and what they did, they had nothing that I could find that was unique in technology. They could make everything cheaper, faster, stronger, and in their industries there was no unemployment. So they had no problem with their labor forces. That was industrial scene. Now you go into this service scene. I'm telling you, they're making big mistakes. There's millions of dollars go into Asimov. What's the reason for that walking robot? It's in Honda's automotive ads so that they can say to you, look how smart we are, you better buy our car. That thing is ridiculous from an expense point of view. It's not going to work. And then all the ones that are happy and pretty. Look, there's no question if you can make a toy that is desirable. As I told some, I said, look, I remember when a pet rock was a big boom. You know, if a pet rock is going to sell, then you can sell all these things that are in the end. I can't tell you what the difference is. I know this. I went to 46 different companies to get funding for Unimation, and didn't get anywhere till the 46th one, obviously. But it's very, very hard when it doesn't exist.
Could I make one suggestion?
Pardon?
Could I make one suggestion? That is the competition.
Yeah.
And I've been through respite care and became a nursing aide to give care to my wife before she died.
Yeah.
But the competition is people who are very easy to program, and thanks to immigration, plentiful and cheap, I believe.
Well, I think you're wrong. Because, look, first of all, I've always said to people, there's no robot as good as a willing worker. That's it. There aren't so many willing workers, though, to take those jobs, a personal attendant job. You probably know it's very expensive to have if you have someone full-time in the house. Well, today you'll pay about $170 a day. They live in your house. They've got to have a room. They've got to have food. They've got to have guaranteed 8 hours sleep. And they've got to have transportation to get around. And then finally, with old people, they've got to be able to cope with the personality of the person. And those are tough to do. I did this for my mother. When I got past the drunks and the drug addicts, finally got somebody that she liked and all. It was a long, tough process. Now, I'm sure it's easier in different parts of the country, but I'm not so sure that if you can get for similar costs. See, I look at this, the robot I'm talking about is going to rent for $1 an hour, but it'll be 24 hours a day. You've got it there all the time, so it's $24 a day. You may still need some help, maybe 2 hours a day of, maybe it's a loving relative. It's all 2 hours a day is not bad. Or you hire somebody like the Visiting Nurses Association, something like that. It's going to cost you $15, $20 an hour. So now you're in for $24 a day and $40, $64 a day. Not $170 a day with food and with all those other amenities and with personality conflicts. And there are personality conflicts. People from any country have their own lifestyle they want to preserve. Now, I found out that the way that people would look at this in South Korea, which I've just been, had to be from the point of view of export product. Because they can hire somebody there for $10,000 a year to take that job. And I just told you ours would be $24 an hour. It's about $600 a month. That's about $7,000 a year. The Health and Human Services would love to pay that. The Veterans Administration would. But you know, there's so many people, they say it's too expensive. I said, what do you mean it's too expensive? It's a cost. That's the other reaction you're going to get. Oh, gee whiz. You mean it's going to cost the price you're going to have to pay like for a Mercedes? I said, yeah. But you'll pay more than for Mercedes. If you rent these to a person's 85 years old, probably doesn't want one. He wants to rent it, have it work for him. And then the people who rent them are going to make money because they'd move them from home to home, so forth. There's a lot of those details, but I appreciate what you're saying because it's very frustrating to try to get through some of the questions that management has. It's going to happen, by the way, whether I do it or not, because the pressure is growing so big. People hate that nursing home. I mean, it's the kiss of death. The elephant's burial ground, if you talk to older people. Please don't put me. Let me stay home. Yes, sir.
So there are many technical challenges to moving from industrial environment to the home environment as far as robotics is concerned. One of them which I'm interested in is the fact that the home environment is much more unstructured than industry. So I was wondering, like for example, if you wanted to make orange juice for you.
Want to make what?
Orange juice. You want the robot to make you some orange juice so you can bring you your glass of orange juice.
You know, in our house, we have orange juice, but we get it in a container. It's all squeezed. And we pour it. That's all. That's it. Now, there's no question you have to bend the environment a little bit. I didn't go into it, but we dealt with an assisted living concern. They're building an $80 million complex. Everyone there is living in a small apartment. There are 4 on a floor, and they all have a kitchen and a bathroom and a living room and a dining area, and they're all very similar. And we looked at it and said, well, I want to make a few changes, just a few. I want, for example, to have pocket doors. Now, if you travel a lot, you'll note that most hotels today have some rooms for handicapped people where the door slides, because handicapped people in a wheelchair have to back up and really horse around to get the side. Let's put pocket doors in all over. And we want a place where it can operate in the kitchen. And, you know, there's not much else, but you can't say that we're going to live with complete freedom for the people. They've got to use things that are partially manufactured already. Some of that's the sacrifice they make. But, you know, if you have a loving relative, like my wife would make ahead some dishes for my mother, even though she had some help, she'd make them ahead, and that's easy, and that can be done. But the other thing that happens, you know, you talk about computer hackers. Think what a wonderful thing this would be for a hacker. It's not only the computer, it's the physical thing that's there they can hack with. They're going to get smarter and smarter with using the robot. One of the things I wanted to do when I tried with the National Science Foundation, let me build 12 of these, and let's put them with 12 of the best university groups and see what each of those groups could make of it. What can they do, what can they do next in application software? That'd be a tremendous thing. Japan tried to do it once with a robot. They ran out of money, and it never went ahead. But I think that'd be a great plan if we could do it.
Amby.
Have you addressed how easy it would be to get older people to comply with basically the structure that the robot would have to have? I was thinking about my grandmother, and she tends to get distracted or forgetful, and maybe intends to put the orange juice where it's supposed to be, but in fact sets it down somewhere else and forgets about it.
Yeah, you know, the beauty of the robot is it's not going to be forgetful. That's one of the advantages. Certainly you'll see that your grandmother gets her medicine when she should, which is important. The robot language in artificial can branch. In other words, a robot can have a number of possible responses to whatever a person says. Like the geriatrician that we're dealing with says, people 85 and older generally have about 5 subjects they'll talk about. And one of them is, what's for lunch? So now the robot is going to be able to say, this is what we're having for lunch. Or, don't you remember, you're going to Johnny's house for lunch today. Or, don't you remember, we just had lunch. I mean, those are the possibilities. So all the memory things are taken off the table. The robot is going to have the memory there. And I'll say one other thing. Don't underestimate the older person. Now, everyone knew how lousy they were with VCRs, and so was I. But I'll tell you, they're all emailing today. Better believe it. They can get by with some level of technology. It's just that if you make it ridiculous, then they're in trouble. Sorry?
Has it actually lived in a home environment with some elderly person? Or how many years more is that?
Well, I've gone through all of this with my mother.
No, I mean the robot.
Oh, no, no. I don't know when you can. This is all, it's speculation. I'm saying we can do it,
Okay.
but you got to do it before you can try
What
it.
could you predict as how many years more in the future?
Well, what you do, I'm sorry, what did I say?
What could you predict how many years more in the future do you think this
You know,
will happen?
you tell me when the clock starts and I'll tell you when it's going to be available. The clock starts when the money's available to do this. And the whole thing, see, when you start the development, it's not going to come out exactly like I did it there, because you start with alpha sites and they try some people with it and you're going to find out it doesn't quite right the way we did it. Then you go to beta sites, which is a bigger, larger group of people. Now you finally got your functional design set. Then you got to do value engineering, which is an engineering stunt to get the most out of it. And then you tool it. And then you go ahead. Now we're talking about a volume that's never been seen in the robot business. Nobody in the robot business is volume manufacturing. They're automation people. They build automation for customers. This is a volume product, different, never before. That's why I bring up this simulation. A luxury automobile is a much more complicated thing to build than the robot I'm talking about, because all the software part of it, the software is going to be, goes with it every time, and you got it, you know. It's in the car, you got to put all those pieces together every time from scratch. Yes, sir.
You talked about an interesting thing about giving the robot a prior knowledge of the environment. Now, I was wondering, suppose, say 5 years from now, you do have these robots going in every homes or several homes. So, how easy is it going to be to give it a prior knowledge of any specific home?
How easy to do what?
How easy will it be to give the robot prior knowledge about a specific house?
Well, let's go ahead. Yeah, it's pretty easy, because you're going to have service with this. Now, just like in our helpmate, we always had service with it. You can't count on the hospital people to know how to take care of this machine. So we do the programming. If something goes wrong, we service it. In installing in the house, most people are going to have toilets that look a lot like other people's toilets. So that's going to say that's a toilet. This is a shower, and each part of the house. And in the kitchen's the same. Now, in the microwave, I want to talk to the microwave. Now, you can do that, by the way. It's a modification. Right now, you twiddle knobs and push buttons. Robot could do that too, but why not just have the robot speak the same language as that? So the way we looked at that differential, we said that probably a house would get about $5,000 worth of modifications that would be different than the house. Another thing that happened, for example, we went around, talked to older people. One of the things you find out with very old people, they have lots of clutter. They've gotten gifts from everybody, and they save them all like little jewels all over the place. And you say, gee, it's going to be hard for the robot to deal with all that clutter. The response I get is, you give me the robot, I'll get rid of the clutter. That robot has a different posture in their mind, because now they're looking at this. This is my savior. My kids are going to put me in a nursing home pretty soon if I can't find some way to live alone. Yeah. Yes, sir.
Part of the resistance among the people that you've spoken to might also emanate from the fact that people may think it's dangerous to have a robot interacting with people. And even today we have manipulators.
Think about safety, huh?
Yeah, because everything comes with this huge sticker saying, don't be anywhere near the robot, there is this work cell, everybody has to be away from the manipulator. So whenever we have this anthropomorphic arms, people want to be away. And here we want them to interact.
Yeah, sure. Now, you got to, after you've been in the business a while watching it, this whole fear. If the whole history of industrial robots, to my knowledge, billions of hours, there's only been 3 people killed by a robot so far. And they weren't just fools, they were damn fools. They had to take a real effort to get killed by the robot, to break all the rules. That's one point. Then I talked to doctors about, I consulted on with IBM on RoboDoc, which is the software for the hip replacement surgery. I said, aren't you guys worried about the robot's not going to be perfect? It can make a mistake. He says, we make mistakes all the time. That's what we got insurance for. You get insurance on your robot, and if it makes a mistake, you pay off. How many people die from hospital? 20,000 people a year die from hospital-contracted disease? Yeah. Yes, sir.
So you asked Isaac to help you get up, but he didn't really do it. He just came over and put his hands out.
Yeah.
And you got yourself up, and then he acted
Remember, he
like
put one arm over the top of me like this. You didn't see it from behind. I could grab onto the arm and slide out. Now, he didn't pick me up. That's not
much more than a walker. So what I'm interested in comparing is the expense and the utility of a general purpose machine that will get you your orange juice and be your walker and clean the toilet versus a walker, which, I don't know, costs $100, and for another $100 I can put the motors and remote control on it corresponding to a radio-operated toy car, and now you have a little joystick. You can bring your walker over when you want to use your walker, just as you did with Isaac.
Well, most geriatrics people say the greatest invention that older people have ever had is the walker. It's a great invention, but it doesn't do anything but help them walk. Now, the walker is a little bit of a handicap, a little bit, not quite as good as the robot arm going out like this over the bed. You hold on to that, and I'm going to help you get up. But you don't discount the other activities. Anytime, that walker is never going to leave you at the television and go to the refrigerator and get you a beer. The robot will. Now, cleaning the bathroom is a distasteful job for a lot of people, and the robot's going to clean the bathroom. And we looked at this at great length for Marriott. Some very interesting things as far as cleaning is concerned. Every time I was staying at a Marriott, the girl would come to clean, and she said, excuse me. I said, no, come on in, let me see what she's going to do. She takes her vacuum cleaner and zips it a few places in the living room so that the fur comes up. It looks like she's been cleaning. And then in the bathroom, they have a rule. You never touch anything that person has laid out. If they're staying another night, you never touch it. Leave it exactly where it is. And so they can't do much about that. So then they show a video, the training video, which is funny as hell, shows a girl on her hands and knees cleaning around the toilet and smiling. Oh, she's so happy to be doing that, you know. And she's got a great big heavy cart she's pushing around to get to the places and so forth. But the point is that you saw on the video that we had a standard industrial robot open a curtain, wash the window, unlock the window, open the window, pour the plants out, and then close the window and close the curtain again. Now, our house, we get our windows washed 3 times a year. So I don't want a special window washing robot, do I? So you start out, what don't I want a special one of? I want a general one whose cost in aggregate will be cheap. So I put it back down to saying, compare it to the cost of help that can do this same thing. I didn't say it could do everything, so I told you got some human help you're going to need anyway. Not only that, human help is an advantage some part of the time, because that's something that makes people feel better if they have some human attention. But you won't get all of those things. Start out with a vacuum cleaner that really vacuums. Roomba vac is there's your $150 answer. In Electrolux, it was $1,500. So they don't work. Just put it near a rug with a frill on it, and the frill all goes stuck in the damn thing, and it doesn't work. And it doesn't clean all over, because it's got to bump into places and find out where it's going. And it doesn't really clean, like a vacuum cleaner does that you can push around on the floor. And you get into the kitchen and, scrubbing the floor. So it's just a big chore. Walker doesn't scrub floors. Walker doesn't put things in the microwave. Walker doesn't put things away in the refrigerator. If you today, you can do your shopping by phone. Online you can shop. At least in Connecticut you can, you probably can here too. You can shop online, they bring it to the door. Fine. The robot puts it away. and knows where everything is then. You don't do that. Robot knows there's in the pantry, this is in the refrigerator, this is in the freezer, and when you want it again, the robot knows where to get it. So, you know, you've taken a stand, which is a logical one, and it's taken all the time. And then it turns out there isn't much of a market for something at what it costs. Now, I'll give you another example. There's a wheelchair now called iBot. I don't know if you've seen it. It's got 4 wheels, very clever design by Dean Kamen. It can rear up on its hind legs and be stabilized with gyros. So it's standing in one place on the gyros. And that means you in your wheelchair don't have to look up at other people. You can look them right in the eye. Okay, $25,000. Now, I happen to have broken my hip. And I knew Dean Kamen, and I thought that if I was stuck in a wheelchair, which I was in for about a month, I would have one of those. I can afford $25,000. What the hell? Sounds like fun. I can get up and reach things. But you know, when I got out of the hospital with a wheelchair, they gave me one of those pickers they have in a grocery store. 19 bucks. And I could reach things with it. That's what the government will buy you. They will not buy you a $25,000 wheelchair that gives you warm feelings. You got to get something that costs less for Medicare, Medicaid, your insurance, long-term insurance, every one of them. They'll be Johnny on the spot if you can say this is going to cost 30% of what you would pay for it in human health.
Well, we know that people over 85 talk about 4 topics. I've concluded that Joe talks about 1, robots and the future of robots. So let's thank him again.
Thank you.
Hi, Joe. Ralph Hollis. We've met a couple of times
right.
at IBM and
Right.
also in Japan, I guess.
Yeah,
Get
right.
one of the Engelberger Awards. Anyway, enjoyed your talk very much.
Thank you.
My apologies for the audio visuals.
Oh, that's okay. Made it in the end.
You know, we had to steal the VCR out of my office.